Hello and welcome. In this video, I'm going to complete a series of tasks for MPLS on OcNOS devices. The task is as follows. Provide evpn VPWS service for Kenzo. Kenzo is my customer down here. It has two branches and I'm going to speak about the topology in a minute. But before that, I want to extend this task a little bit. The task says VPWS, and when you speak about VPWS, what you think of is a point-to-point connection. This point-to-point connection most likely could be called E-line. And you can just change it to E-line service for evpn, which is supported technology on OcNOS devices. The other type of communication that we can have is multi-point to multi-point. You can call this ELAN. And in ELAN, we have something like VPLS. E-line is something like VPWS. There is another type of technology that is point to multipoint or multipoint to point, whichever that you want to call it, and that is specifically called E3. And I'm not talking about this one. What I'm going to do is to configure these two on OcNOS on my topology so that you can see how we can have point-to-point and multipoint to multipoint evpn configured here. Also, I'm not going to go into evpn theory because we have videos for that. You can check them out. But in here, I'm just going to tell you what is the solution for some of the problems that we have before, and evpn provides some features to solve those problems. So, like I said, the task just goes with E-line, but I'm going to have ELAN as well. Okay, let's go to our topology and take a look at what we have here. I have my service provider, which is called OENet Solutions, and it provides us with multiple technologies. Some of them I have discussed in some other videos, for example, VPWS, VPLS, and L3 VPN. These are the technologies that I have implemented here, all of them. I'm going to show you the configuration in a second. What I'm going to configure right now is evpn for this customer down here. So, what are the shortcomings of some other services such as VPLS and VPWS that I am trying to fix it with evpn? I wouldn't say that evpn is a replacement for VPWS and VPLS because each service, as a matter of fact, has some advantages and some disadvantages. evpn is very featureful, but whether or not you need these features is something that you really need to check your design for so that you can understand whether you should implement this technology or not. And also, evpn should be supported on the device that you are having. In here, OcNOS operating system, of course, supports evpn for ELAN and E-line, both of them. And also, we can have single homing like the topology that I have right now, or multi-homing. Let's say, for example, this one has another connection to another PE that is here, and you can use this. In case of multi-homing, of course, you can use both of these links as active, and this is due to some of the configuration that we have in evpn. We don't have such thing in VPLS. In VPLS, I can have multi-homing. I can say, for example, this switch 10 is connected to one PE here and another PE maybe here. And then when I am using this, one of the links could be active, the other one could be passive. The reason for that is when I use this VPLS, what I have is pseudo wires that I'm going to create here between different PEs. Let's say that these are my pseudo wires, or let's go with a thicker line so that we can have a better understanding. And let's say I'm going to use this color magenta here. These are pseudo wires that we have created. And kind of a multipoint to multipoint connection is implemented in here. Now, what happens when my switch sends a frame to router 1? Router 1 is going to learn the MAC address for that. And anytime that it receives a frame for that destination, it knows where it is. So kind of a data plane learning happens on VPLS devices. This data plane learning, of course, has some limitations. and you know, sending the information to the other side so that the other side knows that we know this MAC address. These are the things that are going to, you know, cause some problems for us. The other thing is, in case I don't know where the destination of a specific frame is. When I receive a frame, let's say using flooding on router 1, what I want to do is I'm going to create a MAC to next hop table. And with that, I will understand that this MAC address, for example, comes from router 5 or comes from router 3. And based on that, I can understand where the destination is on VPLS. In case I don't know where the destination is, what am I going to do? I need to flood this message on all of the pseudo wires. So I will send this message over this and over this pseudo wire to router 3 and router 5, which are my PEs in this case. Router 5 receives this, and if router 5 says, okay, I don't know where the destination is, what is the default behavior? It should send it over all pseudo wires again, for example this one, and then in that case router 3 will receive this frame on 2 different directions. So this is going to create kind of a loop in my network. So in VPLS, one of the things that we can do is just to make sure that we don't have any loop, we are going to implement a very simple rule. That simple rule, of course, is going to be inclusive, but it is going to solve our problems, not completely, but mostly. It says that we are going to have something like an IBGP rules. In case I have received packet from, in case I have received a prefix from an IBGP rule, I'm not going to send it to another IBGP rule. That is the rule on BGP, right? We are going to do the same thing here. In case I have received a frame over a pseudo wire, I'm not going to send it on another pseudo wire. So router 3 is not going to send it on this pseudo wire, which ends in router 5. The same thing happens on router 5. Router 5 has received a frame over a pseudo wire. It's not going to send it on another pseudo wire. And with this, router 3 is not going to receive multiple copies of a frame. So this is what we have on VPLS. The other thing that, like I said, we have is, in case we have multi-homing in VPLS, we have an active and passive link. In case both of them are active, then what we are going to see is multiple, frames from different directions. Router 1 will send the frame to router 3, and also router 3 will receive the frame over this physical connection to the customer, which is going to cause a lot of problem loops, like I said. So VPLS is not so scalable in this case. It's not going to utilize all our resources. But in case, let's say I have some kind of a multi-homing connection in evpn, what can we do? We can use both of them as active. Why? Because these are connected to the same customer, and what I can do is I will say, okay, both of these links are going to be in the same evpn segment, and I'm going to allocate an evpn segment identifier to this, and I will say, okay, if I have received a frame on router 1 based on hashing or something that we just send it on one of the links, and router 1 sends it to router, for example, 3 and some other routers, for example, router 5. Router 3 is not going to send it back here because router 3 sees that identifier here, and it will know that this is the same segment that the frame has been received from. And for that, this frame is not going to cause a loop for us. This evpn is not going to cause a loop for us. I'm not having, as a matter of fact, multi-homing enabled in my topology right now, but I'm just going to tell you that this is possible. evpn, of course, has some other capabilities. evpn can carry MAC addresses using control plane, can replicate it to other PEs, and it is not just MAC addresses. it can be MAC address and IP addresses at the same time. There are multiple route types that, like I said, in the theory part, of course, you will learn about them. But you should know that route type 1 to 4 is supported in our topology, and we can just check them out. Okay, so for EVPN, we have a good interaction between BGP and EVPN because BGP has an address family for EVPN, which we are going to create it. Also, when we create this technology, we are going to create a VRF. But this VRF, of course, is of a specific type, which we call it MAC VRF. And we are going to create, like I said, 2 types of them. One of them I'm going to call it Kenzo. And for VPWS, I can just say Kenzo VPWS, or I can call it Kenzo. This is better to be called E-Line. Like I said, this is going to be for VPWS. I'm going to create another one, and I'm going to call it Kenzo ELAN, and this is going to be for kind of a VPLS type of EVPN, point-to-point type, not VPLS type. And when I say VPWS, it is better to be called VPWS should be called point-to-point, and VPLS type should be called point-to-multipoint. So I shouldn't really use those terms when I'm talking about EVPN. So what I'm going to have is E-line, point-to-point, ELAN, multipoint to multipoint, and both of them, of course, can be implemented in OcNOS devices. Okay, time for configuration. Configuration is quite easy, and I'm going to show you some of the prerequisites before we do any coding. You should know that what we need to do here is to make, first of all, we should just prepare the MPLS network here inside my service provider. You can see that I have marked all the links that need to have MPLS configuration and LDP configuration with red. So this is part of it. Then router LDP is going to be configured with a transport IP address, which is going to be the loopback IP address of each one of these routers. And this is general for all of these routers. I have PEs, and this is going to be one of the PEs, and this one is another. R1 and R5 are going to be configured, and all the intelligence goes on these two. So basic configuration is done prior to starting to do anything. And I'm just going to show you what is going to happen on all of these routers, and then I'm going to go to router 1 and 5. So if I just go and open, for example, router 2 and say show run, the most relevant configuration is like this. I have configured a global routing, global IGP for all the internal routers for the service provider. I have used ISIS, of course. For each one of the interfaces which is going to be MPLS enabled, I have used this MPLS command, label switching, and also LDP command, enable LDP IPv4. Also, I have on the router LDP a transport address, which is the loopback IP address of the interface. So this is common between all of these service provider routers. So I'm just going to clear the screen, and let's go to router 1. This one is going to be more important, and also router 5. You can see that in here I have lots of configuration. Each part of the configuration, of course, is important for one customer. Some of them, of course, globally for all of the customers. So you can see that if I just go down, I have some VRFs configured for Globetrotter and Alex. These are for other customers. We don't care about this part. This service template is used for VPWS and VPLS. Of course, we have done it before. As you can see, there are some MPLS L2 circuit, which is for VPWS configured before. We are not going to touch any of them because these are configuration for other routers. The most important part is going to be this one, router LDP. You can see that there is a router ID, which is not required, of course, but you can configure it. Target peer IPv4 address. We configured this for VPWS, but if you have not configured it, now it is a good time to do it because we are going to need it for evpn E-line, which is going to be with VWPS. Yes. And the other one is the transport IP address, which we have just configured here. If I just go down, now the other thing which is going to be important is this Ethernet 7, which does not have any configuration between router 1 and switch 14. And also under BGP, as you can see, for internal service provider configuration, there is only one address family enabled, and that is VPN v4. That's all the configuration that we have, and after that we have nothing. But let's start the configuration of what we are going to do right now. I'm going to do the configuration in 2 steps. Like I said, I'm going to go with E-line and after that ELAN. But the verification commands, all of them are going to be done after my full configuration. So first of all, I'm going to create a VRF for Kenzo. But because this is going to be an evpn service, that should be a little different from the normal VRFs that we have. The VRF is going to be called a MAC VRF. So I'm going to say MAC VRF, and let's say that this is called Kenzo, and I'm going to call it E-line, which is VPWS kind of a configuration. Under this, I need to configure a route distinguisher, let's say 77, and a route target, and I'm going to say both, and after that I can just say evpn auto RT, or I can just type a value. I'm just going to type a value of 77 for this as well. Okay, now that I have done this, the other thing that I'm going to configure is let's say MAC VRF for the other one, ELAN. That is going to be my VPLS type, or ELAN type, or let's say multi-point to multi-point type of the configuration. Like I said, I'm configuring both of them at the same time. RD is going to be 7-8, and route target, let's say that this time I'm going to use auto for this one. So I'm going to say auto, both is going to be evpn auto RT. Okay, so this is a simple configuration that we have here. Now, something that you should know is each one of the devices or PEs that I am using here is called a VTEP in this case. And the terminology is very similar to VXLAN. We are going to have VTEP here. We are going to have VTEP ID and VNID and stuff like that. All of them I'm going to explain to you. But let's say that this VTEP or this provider edge needs to have an IP, or let's say an ID configured for that. So I'm going to say evpn MPLS, and here I would say VTEP ID, and because I'm under the VRF, it doesn't show me the auto completion. So I'm going to say evpn MPLS VTEP evpn. Come on. Okay. VTEP IP global, this is going to be 1111 because this is the IP address which I'm using for my loopback interface. And next thing that I want to configure is the tunnels. The tunnels for VPWS, or let's say for E-line, is going to be configured with a source and a destination. But for ELAN, that's different because we have multi-point to multi-point configuration, which is dynamically created. And for that, we don't have a destination. All we need to do is to just make sure that the same ID is going to be used on both sides. In case we have multiple VTEPs, then on all sides. But here, let's go for the point-to-point type first. For that, I would say evpn MPLS ID. Let's say that this is R1, so I'm going to say this is 1, and the type is XConnect, and then we have a target MPLS ID, which is going to be number 5. On the other side, I'm going to configure exactly the opposite of that. On router 5, I'm going to say evpn MPLS ID is 5, XConnect target MPLS ID is 1. So that is what I'm going to do here. And under this, I'm going to say I'm using BGP for that. So host reachability protocol is going to be evpn BGP, and the VRF that I'm using here is going to be Kenzo E-line. So that is, why do I add an extra N, which I should not? Okay, so this is host reachability protocol with this specific VPN that I just created. So this is for point-to-point. Like I said, there is a source band, there is a destination. But for the multi-point to multi-point tag, I'm not going to use a source and destination, only an ID. So I'm going to say evpn MPLS ID. This time I'm going to say this is a tunnel between router 1 and 5. So let's just name it 15. And under this, I'm going to use the same command, host reachability protocol evpn BGP, but the name of the VPN, of course, is going to be separate than this. So I'm going to say exit. So far, let's commit every configuration that we have done. So there is no problem. Now, I have configured router LDP. Just to show you running configure of router LDP, you can see that this is what you need to have. And I am almost done. The only thing that is left is configuration of the interfaces. Now, like I said, under physical interface, you cannot configure evpn. What you need to do is to configure this under sub-interfaces. So I have to create sub-interfaces here. And I'm going to say I have a VLAN 10 and 11 configured on switch 14. Let me just go to there and first of all log in and say show run. You can see that I have this this one, bridge 1. Under bridge 1, I have configured VLAN 10 and 11, and I have 2 VLAN interfaces, one of them for 10, one of them for 11. 15 is the same, but with different IP addresses. Going back to R1, I'm going to use sub-interfaces. Each one of these sub-interfaces is going to be for one of these services. One of them is going to be used for this one, the point-to-point one. One of them is going to be used for this multi-point one. So let's create the sub-interface. I'm going to say interface ETH7.10. And then I'm going to say switch port. This is going to create an L2 sub-interface for us. Under this, for sure, I need to say encapsulation is .1Q. And the VLAN ID is going to be 10. And I'm going to say access if evpn. And under that, I need to say map VPN ID. And my VPN ID, as you can see, is number 1. The destination VPN ID is going to be 5. So I'm going to say number 1. That's it. Okay, let's exit. Then let's exit one more time. This time, I'm going to create another one. That is going to be this one, 7.11. Okay, no, this one. Exit, and I should not have created this one without switch port. Okay, let's create this one more time, because I added an extra 0 in here. Okay. And encapsulation is going to be .1Q11. Access if evpn. Map VPN ID, of course, is going to be the dynamic one, which is 15 in here. So I need to exit, and commit the configuration for us. Okay, let's show the configuration and then do the same thing on the other side. So what I'm going to say is to show run. So I can just copy some parts of the configuration, and I guess I forgot to do something. I needed to configure address family L2 VPN, evpn under BGP, and fortunately I have done it before, so we are going to do the same thing on the other side. Okay, let's go to router 5 and start the configuration there. What I'm going to start is, first of all, I need to copy this MAC VPNs to the other side. So both of them are going to be the same. So I'm going to use that. This is the first thing. Let me see if there is anything before that. evpn MPLS enable is the other line of command that I just needed to do it. So first of all, I'm going to say configure terminal evpn MPLS enable. Then the Mac VRFs are going to go to there. And after that, let's just do the first commit. Okay, so this line is done. Mac VRFs are done. Now, evpn MPLS VTEP global ID is going to be 5555. Okay, there is a 5 here missing. The next line of command that I need to do is this one. But for this, like I said, I need to flip the numbers. So I just go to here and say my target is 1, my ID is 5. And under that, this line is going to be similar. Also, this one, of course, is going to be similar because this is dynamic, and I just made sure that both sides are going to have the same ID. So I'm going to just paste them here. And let's do another commit. Going back to here, I would say that rather LDP configuration should be checked on the other side. So I'm going to say show run rather LDP. Here it is. Everything seems to be good. And the other thing that I need to do is to configure Ethernet 7 configuration switch port. And the configuration is exactly the same as what we have here. So I'm going to just copy everything and put the other side. Of course, here map VPN ID should be changing to 5 because that one is different. So I'm going to say map VPN ID is 5. But the dynamic one, of course, is going to be the multi-point one, of course, is exactly the same as what we have. So I'm going to go to here and exit. And exit one more time and paste this configuration here. Exit again and commit the configuration. Okay, so that is what we have for this, and there is an extra interface here that I don't know when I have created that. I don't really care about this because it's not important. Now, the only thing that is left is rather BGP 100. I go to here and I say rather BGP 100. Under this, I need to make sure that my neighbor is enabled. Under address family L2 VPN, not the evpn, address family L2 VPN evpn. And the neighbor is going to be 1111 activated. And I need to say commit. And that will do the configuration. So my configuration is done. I need to save the configuration. Here I need to do the same thing, save the configuration. And now it is time for some verification commands to check. So the first verification command that I'm going to do is to first of all see whether those tunnels are in place. So let's start from one of these. Doesn't matter, router 5 or router 1. Let's say router 1, for example. I'm going to say show Mac VRF and let's say Kenzo E-line. This is my import VNID and export VNID. VNID stands for Virtual Network Identifier, or VXLAN Network Identifier, sorry. VXLAN Network Identifier, exactly the same term which is used for VXLAN. And like I said, that's VTEP, of course, is another term that we use for VXLAN. And there are some information here, for example, route distinguisher, route target, but because we have just configured all of them manually, you can just see that. These are exact numbers that we expect. Next thing is going to be for ELAN. So I'm going to say ELAN, and here things are a little different. You can see that import and export are the same, but we have configured the same thing on router 5 as well. the route target is automatically created for us, and that is because we just set auto route target. Next command, which is very important, show evpn MPLS tunnel. And after that, you can just say summary or label. We are going to go with label, but I'm going to say tunnel. You can see that this is the dynamic tunnel which is created for us using this evpn ID of 15. But if I just go to here after MPLS and say xconnect tunnel, it's going to show us the manual tunnel with the source and destination that we have created. The local evpn ID is 1. The remote one is 5. So that is exactly what you have here. Now, after that, you can see the MPLS. Let's say evpn MPLS ID. This one is important. Here we have 1 and also 15. So you can check them, and there is information about what is the source address, what is the destination address, and what is the VPN ID, and the type of it, and everything that you need to know. And in case you run some traffic, then MAC table is going to be populated. And for that, you would say show evpn MPLS MAC table. And because I have not run any traffic, so MAC table is empty for now. There is no entry in that. So that is the most important part, but like I said, you can just say show evpn MPLS. If I go with xconnect tunnel, this is what we have seen before, but I'm going to add label. You can see that the labels which is created for us. And also if I just remove this xconnect, this is going to show us the dynamic one. And these labels are different from the labels that we had before. So that's almost that. And you can run the same verification commands on the other device just to see what is happening for evpn. With this, our evpn configuration for both E-line and ELAN is complete. And now we should have reachability from switch 14, any VLAN interface or any device that we have here, to the other side in case you have the traffic on VLAN 10 or 11. So I hope this has been informative for you, and see you in next videos.